This is the first page they'll have you do. This is counterbalancing. This will be your data set that you'll plug your numbers into. Instead of using McDonald's and Burger King, I'm using Pizza Hut and Roundtable. So PH is Pizza Hut, RT is Roundtable. What I'll have you do first is you have to, well, these two people right here are getting Pizza Hut first and Roundtable second, and this person right here is getting Roundtable first and Pizza Hut second. What I want you to do is make up the ratings that these two people would give to Pizza Hut at time 1 when they're doing a taste test. And they can be any number on a 1 to 7 scale, 1 being liking it the least and 7 liking it the most. So you could say that this person gives a 7, this person gives a 6 to Pizza Hut. Then for person 3, I want this person to give a rating to Roundtable, which they're trying at time 1. You can just make up any rating on a 1 to 7 scale. Then what I want you to do for these other ratings at time 2 is we'll make up ratings again. So make up a rating that these two people would give to Roundtable at time 2. But whatever rating you make up, subtract it by 1 because of fatigue, because they're starting to get tired of pizza at time 2. So what I'm having you do is make up a rating that they would have given to Roundtable without any fatigue. But since they do have fatigue, the rating is dropping down by 1, and this is what their actual rating ends up being. So here, make up another rating. Maybe you're saying that they would have given Roundtable a rating of a 6 if they had it at time 1, but because they're having it at time 2, the rating is actually a 5. And do the same thing over here. Make up a rating that person 3 gives to Pizza Hut when this person has Pizza Hut at time 2, but then subtract that rating by 1 because of fatigue. And the actual rating ends up being this number. So you're just making up all of these ratings, but for all of the ratings at time 2, you're subtracting each of them by 1. What you'll do next is you'll calculate the mean of the Pizza Hut condition and the mean of the Roundtable condition. To do that, you'll add these 3 numbers and divide the total by 3. And remember that this right here is the actual rating. So this is what gets included in the calculations. So it would be 7 plus 6 plus 4 divided by 3, and that would be the mean. These are the actual ratings, so it would be 4 plus 5 plus 5 divided by 3 to get the mean of the Roundtable condition. And you won't be using these exact numbers because I'll just let you make up your own numbers. And actually, I'd like for you to use numbers that I didn't use. So then you'll get the 2 means right here. And then right here, you'll calculate the mean fatigue of the Pizza Hut condition and the mean fatigue of the Roundtable condition. And I'll show you what I mean by these right here. If since these 2 people right here are getting Pizza Hut at time 1, we'll say that the fatigue score equals 0 because they don't have any fatigue yet. So this is 0, this is 0 for fatigue. And this score right here also has a fatigue score of 0 because it's happening at time 1. So, and all of the time 2 scores have a fatigue score of 1. So this would be 1, 1, 1. Just think of it this way. It's the same number that we have right here. So it's so what you would do to calculate the mean fatigue of the Pizza Hut condition is you would add up all of the fatigue scores in the Pizza Hut condition right here and divide the total by 3. So it would be 0 plus 0 plus 1 divided by 3, because this has a fatigue at 1 at time 2. Remember, time 1 is a fatigue of 0, time 2 is a fatigue of 1, so it would be, the fatigue scores would be 0, 0, 1. And you would add those three numbers, 0 plus 0 plus 1, and divide by 3. That's the mean fatigue of the Pizza Hut condition. The fatigue scores in the round table condition are 1, 1, 0. So you would add those three numbers and divide the total by 3 to get the mean fatigue of the round table condition. And then you would look at the two fatigue scores, and if they're equal, then the results were not affected by fatigue. The answer would be no, because in that case, fatigue affected the two conditions equally. This is which condition was affected the most by fatigue. Well, let's go back to question 1 for a second. If these two numbers end up being different, then the results were affected by fatigue, because one condition had more fatigue than the other, and the answer here would have been yes. And then, if the answer to this one is yes, then what you would say for question 2 is you would look at the condition that has the highest fatigue average, and then that would be your answer for the condition that had the most fatigue. But if the two fatigue scores are equal, if they're the same number, then you would say no to question 1, it's not affected by fatigue. And then for question 2, you would just say they were affected equally. So either if these two numbers are equal to each other, then this answer is a no, it's not affected by fatigue. And the answer to question 2 would be neither was affected more by fatigue. If the two numbers are different, then this answer is yes. And then for question 2, you would just tell me which condition had the higher fatigue average. This says what condition had the advantage in the experiment. Well, if these two numbers are different from each other, then the condition that had the average is the condition that has the lowest fatigue. So you would take the condition that has the lowest fatigue average and say that that one had the advantage in the taste test. But if they're equal to each other, if the fatigue averages are equal, this answer would be neither condition had an advantage. This says, how can you tell that the experiment was not fully counterbalanced? Well, it's just because you have two people assigned to this order and only one person assigned to this order. So it's not equal. You don't have an equal number of people assigned to the two orders. Let's look at the next page. Here you're doing everything over again in the same way. You're filling out the same data set. But the only difference this time is that we have two people assigned to this order and two people assigned to this order. Which means that for question 4, you'll say that actually, this last, how can you tell the experiment was fully counterbalanced? And you'll just say because an equal number of people were assigned to the two orders. Let's look at the next page. I'll have you do reverse counterbalancing, and this says fatigue is linear, which means that the fatigue keeps going up in equal steps across the time points. So at time 1, there's a fatigue of 0. At time 2, there's a fatigue of 1. Time 3 is a fatigue of 2, and time 4 is a fatigue of 3. It's going up in equal steps. And what I'll have you do is I'll have you just fill in these, I'll have you fill in this right here with made up ratings. So maybe you'll make up 5, 4, 3, 6. They're on a 1 to 7 scale. So you've made up all of your ratings for Pizza Hut at time 1. Once you do this, I'll have you go to Pizza Hut at time 2, and then you'll take the same ratings, but you'll subtract the fatigue effect, which means um, the fatigue is 0, 1, 2, 3. Since fatigue is at a level of 3 at time 4, I'll have you subtract each of these other ratings by 3. So they'll give the same ratings, but now at time 4, each person is now giving lower ratings because they're starting to get tired of pizza at time 4. And try to choose ratings so that you won't end up getting anything lower than a 1. And I ended up getting a 0 here. Um, if you do end up getting it, well, it's on a 1 to 5, it's on a 1 to 7 scale. So um, just to keep things simple, pick ratings over here where um, these ratings will end up being no lower than 1, which means I shouldn't have picked a rating lower than 4. So I'll change this to a 4. So now this becomes 4 minus 3. And this is 1. Then for this, I'll have you do 6 minus 3. And that's 3. So these are now the actual ratings that these people are now giving at time 4. Now I'll have you I'll have you make up ratings for Roundtable at time 2. But since it's at time 2, what I'll have you do is start out by making up the ratings that they would have given if it had been at time 1. They're on a 1 to 7 scale. But then account for fatigue. So you would subtract each of these by 1 because it's at time 2. And you have a 1 unit of fatigue. So these are the actual ratings. Now what you do is take the same ratings that you gave to Roundtable at time 2, and what you can do is take the ratings that you gave right here, they would have given to Roundtable at time 1 with no fatigue, and now subtract them by 2, because now you're at time 3 and fatigue is getting higher. You're getting more and more tired of the pizza. Wait, this should have been a 4. Okay, so we have these ratings, these ratings, these ratings, and these ratings. What you'll need to do next is calculate the average Pizza Hut rating and the average Roundtable rating for each person. So to do that, you would add, for person 1, you would add their 2 Pizza Hut ratings, which are 5 and 2. Remember that the actual rating is this one right here. So 5 plus 2 divided by 2 would be this one. And the first person also has a Roundtable average, which would be 4 plus 3 divided by 2. Remember that this is the actual rating, and this is the actual rating, so 4 plus 3 divided by 2 would be the Roundtable average. You would do this for all 4 people. So for person 2, it would be, for Pizza Hut right here, it would be 4 plus 1 divided by 2. That would be the answer. And for Roundtable, it would be 3 plus 2 divided by 2. That's the answer. Once you have all of these filled out, you add these and divide by 4 to get a mean. You add these by 4 and divide by 4 to get a mean. And you get the mean for Pizza Hut and the mean for Roundtable. And you can actually look at which condition came out ahead. Which one did people appear to like more? You can find that out by just looking at which mean is higher. To find out whether the results were affected by fatigue, you have to calculate the mean fatigue here and the mean fatigue here. To do that, you would, for Pizza Hut, you would add up all of the fatigue scores for Pizza Hut. So these at time 1 are all fatigue scores of 0. At time 4, these are all fatigue scores of 3. 3, 3, 3, 3. So you would go 0 plus 0 plus 0 plus 0 plus 3 plus 3 plus 3 plus 3 divided by 8. And that would be the fatigue of Pizza Hut. So you add 4 zeros and you add 4 threes. And that's you're adding 8 numbers, and then you divide the total by 8. That's the answer here. For Roundtable, these are all fatigue scores of 1, because time 2 has a fatigue of 1. And time 3, these all have fatigue scores of 2. So it's 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 divided by 8. That's the mean fatigue in the Roundtable condition. If the 2 fatigue averages come out equal, then you would say no, because the results are not affected by fatigue. If they come out differently, then the answer is yes. One condition was affected more than the other one, so the results were affected by fatigue. If these two are equal and the answer to this one is no, then you would just say here they were affected equally by fatigue. If these are not equal, then the answer is yes to question 2. And for number 3, you would just look at which condition has the highest fatigue average, and that would be the answer. This says which condition had the advantage in the taste test. If these 2 fatigue averages are equal, then neither had the advantage. But if one fatigue score is higher than the other one, then the condition that had the advantage would be whichever one had the lowest fatigue average. So if this number is lower than this number, for example, if Pizza Hut came out to 4 and Roundtable came out to 7, then the one with the lowest fatigue has the advantage in the taste test, which would be if it was 4 and 7, then you would say Pizza Hut had the advantage. That would be the answer because they had less fatigue. And I just made up those numbers. How can you tell that it's fully counterbalanced? Well, it's because each person gets one order and the other order. So every person experiences the two orders one time each. Let's look at the next page. This page is the same thing over again, except now fatigue is not linear. So instead of fatigue going 0, 1, 2, 3, it's going to go 0, 1, 3, 3, which means that all of the time 2 scores will be subtracted by 1, but all of the time 3 scores will be subtracted by 3, and all of the time 4 scores will also be subtracted by 3. So they're getting more and more tired, but it's following a curve and not a straight line. And at the end, you'll tell me what this is showing to be true about reverse counterbalancing. After this, I'm going to have you doing some exercises with factorial designs. The first one is a 2x2 factorial design. See if I can scroll this up. Okay. So each number in here is a recall score. Like these two numbers are recall scores. Same here. We have 8 recall scores from 8 people. We have different types of music, and we have different temperatures. And what I'll have you do is calculate the cell means and fill them in. Since I'm giving you 2 numbers, each cell mean, it can be found by adding the 2 numbers and dividing by 2. There's a shortcut because since there's 2 numbers, it's the number that's halfway between, which means this is whatever's halfway between 8 and 10. This is whatever's halfway between 6 and 8. After you fill all of these in, I'll have you calculate the marginal means. To get this one right here, you add the 4 classical scores, recall scores, and divide by 4, and that's your answer. Here you add these 4 numbers and divide by 4, and that's your answer. To get these marginal means for the temperatures, for this one, you add the 4 recall scores in the top row and divide by 4. That's your answer. For 80 degrees, you add these 4 recall scores and divide by 4. That's your answer. I want you to show your work for calculating the marginal means. So just show me how you're adding up the numbers and dividing by 4 on paper. Here you'll just write out the design of the experiment in this type of format, which you usually see in an article. You fill in the names of the independent variables and the levels. You're telling me what's the dependent variable. It's whatever these numbers stand for. It's what we're recording. Is there a main effect of type of music? Well, if the 2 marginal means for music are equal, then the answer would be no. But if they're unequal, if these are different, then the answer is yes. For the main effect of temperature, that's the next question. Is there a main effect of temperature? If these 2 marginal means out here are equal, the answer is no. There's no main effect. But if these are not equal, then the answer is yes, there is a main effect. The next question asks if there's an interaction. To be able to find out if there's an interaction, you have to you have to look at whether the cell means are parallel or not parallel. If they're parallel, then there's no interaction, but if they're not parallel, then there is an interaction. And I can have you make a graph on your paper to find out if there's an interaction. You can do it like this. You just have to pick one of the two independent variables to go on the x-axis. If you want it to be type, if you want it to be type of music, that's fine, or it could be temperature. You have classical and silence, and then what I'll have you do is well, I'm sorry. To make this graph, this is recall, and then you would take the you would plot the two classical averages, which are at 60 degrees and 80 degrees. So let's say that this one comes out here, this one comes out here. Maybe this one is for 60 degrees, this one is for 80 degrees. And then these two averages in this row, right in this column right here, let's say they came out to these two numbers here and here. This one is 60, this one is 80. So right here, we just have the two cell means, here and here. These are the two x's. Here we have the two cell means in this column, here and here, right here. So it's just the four cell means. You draw a line to connect the two 80-degree cell means. You draw a line to connect the two 60-degree cell means, like this, and you have a graph. And you have to connect horizontally. You don't connect vertically. And if the lines are parallel, there's no interaction. This looks like no interaction. But if they're not parallel, then there is an interaction. And then that can get you your answer to the next question. Is there an interaction? Yes or no? You have to choose an answer to describe what you think the interaction looks like. What is it showing to be true? And you answer this question, number 7, based on your earlier answers. Your earlier answers will tell you what the answer to question 7 is. And I just have some other examples of another 2x2, just with different numbers. This is another 2x2 with different numbers again. But right here, I'll have you do a 2x3 with 3 types of music and 2 temperatures. You'll calculate all 9 cell means. You now have 3 marginal means for types of music. It's these 4 divided by 4, these 4 divided by 4, and these 4 divided by 4. To get these marginal means for temperatures, for this one, you would add the 6 numbers up here and divide by 6. For this one, you would add the 6 numbers in here and divide by 6. If all 3 of these marginal means down here are equal, if they're all the same number, there's no main effective type of music. But if at least one of them is different than the others, then you would say there is a main effective type of music. There's only two of these, so if they're equal, there's no main effective temperature. If they're unequal, there is a main effective temperature. To find out if there's an interaction, you can make the same type of graph. But now you have to make 3 tick marks down here for 3 types of music: classical, jazz, and rock. And recall the dependent is still on the y-axis. These two marginal means, no, I'm sorry, these two cell means right here and here in the classical column would be plotted above C. The two marginal means for jazz would be plotted above here, and the two marginal means for rock would be plotted up here. And then you would draw a line connecting all of the 60-degree means, connecting this, this, and this. So let's say it turns out like that. You would draw a line connecting this, this, and this, meaning all of the 80-degree cell means. And it might be like this, or it might cross over. If they're parallel, like this, there's no interaction. But also, if it's something like this, where this goes up like that, and this goes up the same way, that's also no interaction, because, well, think of it this way: these two are parallel, and these two are parallel. So, or you could think of it this way: this line is the exact same as this line up here. They're exactly the same line. So, the effect of the music is exactly the same at the two temperatures. So no interaction here. This would also be no interaction, because the effect isn't changing across the temperatures. But if you had something like this, where this goes up like that, and this stays flat, that would be an interaction. Or if you had something like this, where this goes up like that, and this goes, if this goes up like this, and then this goes down like this, that's an interaction. So it's a little bit more complicated, or it's a little bit harder. It's a little bit harder to tell if there's an interaction if it's a 2 by 3 and not just a 2 by 2. But you have to just look at whether the two lines are the same, or if the two lines are different, like they are here, or like they are here. I was also going to have you do, well, this is another 2 by 3 with different numbers. I was going to have you do this is the last one, a 2 by 2 by 2 factorial design, which means we have actually 2 temperatures, 2 types of music, and we're also giving all of these participants over here can drink water during the experiment, but all of these participants over here cannot drink water during the experiment. So water is either available or not available, which means we actually have 2 times 2 times 2, 8 conditions that we're assigning 2 people to each of the 8 conditions. the cell means and marginal means can be calculated the same over here that you did before, the same way you did before. You can calculate these cell means and these marginal means the same way that you did before. But in a three-way factorial design, with meaning three independent variables, there's a new type of result that can be found that couldn't be found before, and it's called a three-way interaction. And what is this? It is a result in which the interaction changes across the levels of the third independent variable. This is the easiest way to think about it at first. So here's an example. If these people over here do have an interaction, meaning non-parallel, like this, but these people over here don't have an interaction, like this, meaning they are parallel. Like if this is available, this is not available, then that would be a three-way interaction, because one level of the third independent variable, which is available, has an interaction, but the other level of the third independent variable has no interaction. The lines are parallel. So the interaction is changing across the two levels of IV3. Available and not available. Or, but if you have something like this, where the available condition over here has an interaction, and this condition over here also has the same interaction, like this, that's no three-way interaction, because the interaction is not changing across the levels of the third independent variable. So here we do have a three-way interaction, because the interaction is changing from here to here. But here we have no three-way interaction, because the interaction is not changing. It's the same thing across these two different conditions right here. So here you'll fill in everything for the design, and here you'll answer these questions down here. You'll put a check mark next to each result that you found.